direct substitution versus synthetic substitution. So direct substitution, we've done that before. We did that in Mod 1 with composition of functions when you just plug in a value for all the x's. So if x equals 3, I'm going to plug in 3 for all of the x values. And then I'm just going to simplify that. So this f of 3 becomes 2 times 81 minus 5 times 27 minus 4 times 3 is 12 plus 8. 2 times 81 is 162. Negative 5 times 27, that is, what is it, 135? Minus 12 plus 8. And then we can simplify this. So this is what direct substitution looks like. And then we do 162 minus 135 minus 12 plus 8. And I think we should get 23 there. I'll double check that on my calculator. Make sure I did my math correctly. And it is 23. Good. Okay, so that's what direct substitution looks like. We've done that before. That should not be new for us. But what I want to talk about is this other thing called synthetic substitution. And the way synthetic substitution works is you're going to take all of the values, all the coefficients from in front of the numbers, and you're going to take one as well. There's a 0x squared, so we're going to add that in as well because there's no value there for 0. So we're going to do a 0x squared as well, and we're going to rewrite it a little differently. We're going to say, like an upside down division bar kind of. And I'm going to do 2, negative 5, 0, because that's where my x1 goes to, negative 4, and 8. And again, those are just the values from up above, the 2, the negative 5, the 0, the negative 4, and the 8. That's just the descending order of my values. And what we can do is we can put a 3 over here, which represents our x equals 3. And the way this works is if I take this 2 and I just drop it out of the box, and then I take 3 times 2, I put it back in the box. So to put it back in, I multiply it by 3, so that becomes a 6. All right, let's do that a little cleaner. We're going to do times 3. That gives me a 6. And then I add that column together. Negative 5 plus 6 is 1. And then I'm going to do it again. I'm going to do another times 3. Every time I put this number back in the box, I'm going to multiply it by 3. And just hang with me. We'll see what happens when we do this. I get 0 plus 3 is 3. I'm going to multiply by 3 again. 3 times 3 is 9. And I'm going to get 5. And then I'm going to multiply by 3 again, and I'm going to get 5 times 3 is 15. 8 plus 15 is 23. What I want you to notice is that we ended up with 23 on the left side with direct substitution. Which is this other thing called synthetic substitution. We also ended up with 23. All right. Kind of weird, but yeah, that's another way to find the value using this thing called synthetic substitution. It's our first time looking at it, but it's just another method. All right, so which method do you guys like better? We're going to use long division, except we're going to actually, I guess we're going to use synthetic division here. This first part here, it says x cubed minus 2x squared plus 5x minus 6. This needs to be a plus 3 otherwise it won't work, needs to be x plus 3. Alright? Alright, otherwise it won't work, so use a plus 3 instead.
3.
Yeah. What's up?
Go back to the current worksheet, the synthetic substitution method.
Oh, sorry, up here. Bam. So you just need to get your notes in. Alright. So what we're going to do is we're going to do this synthetic division method. Alright, and it's just very similar to the synthetic substitution. So we have this x plus 3 here. Alright?
Yeah.
And I'm going to fix that down here as well. X plus 3 down here. It's got to be fixed in both places. Right? So we're going to write the coefficients of the dividend in order of descending exponents. So it's already written that way for us. And we're going to draw the upside down division bar with the coefficients inside. So we're going to do 1 for the x cubed, -2 for the x squared, 5 for the x value, -6 for the single value. Okay? Then from there we have this x plus 3 equals 0. We're going to solve for x and we're going to put the solution on the left side of the box. So as x plus 3 equals 0, I'm going to subtract 3 from both sides. I'm going to get x equals -3. Alright. And there's my solution right there. Okay? And now I'm going to do this synthetic method. So once it's set up, alright, I'm just going to draw it again down here. 1, -2, 5, and 6. I'm going to bring down the leading coefficient. And I'm going to multiply the leading coefficient by the value outside the box. So in this case, I'm going to multiply it by -3. And I'm going to write that product under the second coefficient. So we'll start with bring down, the leading coefficient. I'm going to highlight that. Alright, the second part, I'm going to multiply the leading coefficient by the value outside the box. I'm going to put it back in the box. The third part, and I'm going to write that product under the second coefficient. The third part I'm going to do is I'm going to add. So -2 plus 3, and that's going to get me -5. Alright. That's the idea here. Okay. Then, after that, step 3, I'm going to just write it again. Whoops. We're going to repeat this. 1, -2, 5, and 6. And I had the 1, I had the -3, which gave me -5. I'm going to repeat it. I'm going to say -5 times -3 is +15. 5 and 15 equals 20. 20 times -3 is -60. Oops, and this was a -6, not a +6. And that gives me -66 down there. So, again, just multiply the previous sum by the value outside the box. Oops. So -5. I'm multiplying that, and I'm putting it back in the box. And then I'm adding again. All right. And then I'm going to repeat for the remaining coefficients. and then I add. The final sum is the value of the remainder. So if we were doing division, the final sum would be the remainder. It would be negative 66 over what we started with was the x plus 3. That's the remainder in the divisor. Something else that happens here, I have this 1 minus 5 and 20. That's technically 1x squared minus 5x plus 20. 1x squared plus 5x plus 20. And the reason I wanted that to be x plus 3, which I forgot to change, is because I'm comparing this to the warm-up problem that we did, polynomial long division. We'll come back down. But problem number 1, x squared minus 5x plus 20 minus 66 over x plus 3. How do these coefficients compare? They should be the exact same. Okay? We ended up with x squared minus 5x plus 20. We're essentially doing the polynomial long division, but we're doing it without the variables this time. And we're using this weird synthetic method instead. Okay. Now, which one do we think is going to be easier? Polynomial long division or synthetic long division? And I'm hoping you'll say synthetic might be easier because I don't have to deal with all those x values, the x squareds, the x cubes, x to the fourths, anything like that. All right. That's kind of the key for these types of problems. Okay. So that's the trick for example A there. Let's look at one more example together. Use synthetic division to divide. And this is x cubed minus 4x squared plus 6. Just like we did with polynomial long division, I see it's an x cubed term. So it should have 4 terms. This one only has 3 terms. So I'm going to need to put a 0x in there. And now if I'm setting up my division bar, I say 1, negative 4, 0, and 6. And then I have this x plus 3 equals 0. In order to use polynomial long division, I have to solve for x, and that's the negative 3 that goes out here. Okay. And now I'm going to drop the 1 down. I'm going to say negative 3 times 1 is negative 3. Negative 4 plus negative 3 is negative 7. Negative 7 times negative 3 is positive 21. I'm going to get a 21 there. Negative 3 times 21 is negative 63. And because it's a positive 6, I'm going to get negative 57. And again, this is going to be my remainder right there. This part over here, this is my quotient. So that went a lot faster than polynomial long division did. I really like that. So my quotient becomes x squared minus 7x plus 21, and then my remainder minus 57 over my divisor x plus 3, what I started with. But yeah, we'll see that our divisor starts over here. Our dividend was this thing right here, and that's the dividend. So we're just a different setup, but it's the same general idea. We're still gonna, okay. We're still going to end up with something there. Okay. All right, so why don't you guys try example C then? I'll go over it in just a minute, but you guys try C first. All right, let's take a look at this one. So again, make sure first you see a 4th degree polynomial, so there should be 5 terms. And there are 1, 2, 3, 4, 5 terms, so that works out. And then I have an x minus 2 there, so I just need to rewrite that as x equals 2 so I get my divisor set up. And now I can go ahead and do my my division process here. But it's kind of weird because I'm not really using division. I'm just going to be using multiplication. 1 times 2. And then negative 8 times 2 is negative 6. Negative 6 times 2 is negative 12. That gives me a positive 6. Positive 6 times 2 is 12. Did I do that wrong? Oh no, sorry, it should be a negative 6 again, and that should make us a negative 12. And that makes this a 1. 2 times 1 is 2. And then I get negative 2 plus 2 is 0. So this one giving me a remainder 0. And then my quotient, again, here's my quotient. After I divide by a polynomial like x minus 2, my quotient is just going to be 1 degree less. So it was a 4th degree, now it's a 3rd degree. It has 4 terms in it. X squared minus 6, or x cubed minus 6x squared minus 6x plus 1. And then my remainder is 0, so that's how this is going to end. Alright, so what does the result of example C say about the factor x minus 2? That's a little typo. That should really say the divisor. Because what it is telling us is it's telling us that x minus 2 is a factor. Okay? So I just kind of gave you the answer there on accident. So it says the divisor, x minus 2, is a factor. Okay, and that's because I have a remainder 0. For problem 2, because it started with a 2x plus 6, I can go ahead and divide it, and I'm going to end up with like this x equals negative 3. And I can use that negative 3 still just the same way, and I'm going to get negative 4 times negative 3, that gives me negative 12. You're going to get negative 18 there. Negative 3 times negative 18 is a positive 54. Negative 3 times 54, that is negative 162, and I end up getting negative 155. So this one I got 4x squared minus 18x plus 54 minus 155 over 2x plus 6. All right. And then go back to worksheet number 20, check your answers, and it should match up, right? So you guys check your answers on, not worksheet 20, worksheet 21, I'm sorry. That's last time was worksheet 21. But check your answers from Tuesday, and you should see that the long division should check out, right? It works either way. And even have their worksheet 21 in front of them that they can verify that they're right. Go ahead and take a second and look at your worksheets, make sure. Or did I do something wrong?
The answer in the worksheet is different from that answer.
Which one? Problem 1?
Problem 2.
Problem 2. What's different about it? I mean, we got the same remainder, right?
Yeah, but the equation is, or the answer was 2x squared plus 9x plus 27x.
Okay. It was plus 9x plus 27x? Or plus
Yeah.
27? Alright. So, yeah, there's something from last time where we said it was 2x squared plus 9x plus 27. I'm going to pull up my notes and see. Yeah. I had minus 9 from last time, but yeah. But yeah, so this is what the answer looked like last time. Minus 9x plus 27 minus 155 over 2x plus 6. So it's this same remainder, but a different quotient. Is there a relationship between the 2x squared, the 9x, and the 27, though, with the 4x squared, the 18x, and the 54? Some type of relationship between those two? What do you guys think?
The second one was doubled, or it was just doubled to get it.
Exactly. The second one's doubled. And what happens is, right here, when we're doing this step, we're losing that 2, that 2x plus 6, because we're dividing everything by 2. So theoretically, we'd have to divide our answer by 2 to get the same result. So the key is there are going to be some problems with synthetic division. And that's whenever we have a value that's not just like x plus or x minus, whenever it's a 2x or a 3x plus or minus. All right, it will be, that'll be like the problem. All right, so we just have to be careful with, those types of problems specifically. Otherwise, you're always going to get the same remainder. So if you're doing synthetic division correctly, you should get the same remainder as if you did long division, but you might get a different quotient. So the key here is pretty much you don't want to use synthetic. You don't want to use synthetic division on problem number 2, really. You could, but I mean, you just have to watch out for your quotient, and you have to be mindful of that. All right, so anything where there's a 2x plus 6, 3x plus 4, anything that's not just a regular x plus or x minus, you probably don't want to use synthetic division on those problems. Okay. All right, I got 2 more practice problems for you guys to try. All right, so the last 2, just doing these division problems. Divide this one by that, and then there's the x to the 5th, 16x to the 3rd. So this x to the 5th should have 6 terms, so there's going to be a lot of 0 placeholders on that one. All right, but just practice rewriting your expressions out after you've finished the division. All right, so work on those last 2 problems now. All right, so I got those answers written down for the last couple of problems here. All right, just make sure you're checking your work. The key is being able to write it back in the other form once you're done. So it was like x to the 5th, and I'm dividing by a single polynomial, so an x to the 1st power. So I got to be able to write it back x to the 4th, x to the 3rd. Okay, and I just got to remember how to do that. I got to do my reminder, and then I have 1, 2, 3, 4, 5 terms, so it's going to be an x to the 4th power. So being able to write those back in the other form is super, super important there. All right. Okay, so as far as your guys'